Okay, well, I think we'll get going. There's quite a few more people registered, but we understand at this time of year things are a bit crazy out there. So welcome everybody to this webinar. I'm Kim. I've been working at Cognition now for 11 years, facilitating in maths, leadership, assessment and integrated curriculum. So I did 16 years teaching before that, and I was highly involved in music and the arts, and then fell into the maths role where it's all highly connected. So I am presenting this today on behalf of my colleague Heather Lewis, who is at a school and she'll be joining us halfway through. And Julia is joining us as well. So Julia, would you like to introduce yourself, please?
Yes, sure. Kia ora, everyone. I'm Julia Crawford and I'm a facilitator with Cognition Education, and I do a lot of work with intermediates and secondary schools, mostly in mathematics education. And yeah, I'm here just to support Kim in her work that she's doing, and hopefully can be the behind the scenes person with different bits and pieces if we need to do it as well. So yeah, happy to be here, and thanks Kim for running this workshop for us all.
Pleasure. Okay, so it's a bit of a talk fest. This is quite a little bit hard of how do you get measurement concepts across in a 2D sort of platform. So we'll do our best. So I'm just going to share my screen with you. Have a couple of interactives to help along the way. So are you seeing the slideshow?
Yep. Yes.
Yep. Okay, so Heather wrote this around engaging ways of getting children understanding some of these key concepts in measurement, and particularly today we're going to be looking at length. So we're going to look at the key concepts that underpin the development of measurement, some tasks around that, and a little bit around estimation, which is so important in measurement. And I think measurement in our maths curriculum is one of the hardest things to do well. There's so many bits to it that just go either unknown or misunderstood. So let's give it a go. So you will have a link in the chat. If you could go on to that. Actually, I'm not going, while you're doing that, I'm just going to get you to do a quick estimation first here, and you should still be seeing it on my screen. Is that right? Great. So here is a man called Mr. Staddle, and he wrote the Estimation 180 website, a great website. So estimating, looking at him there, what do you think would be an estimate for how tall he is that would be, first of all, too high? What do you think he'd be? Either just say it out loud, or if you want to put it in the chat, I'll get Julia to monitor the chat while I'm sharing my screen.
2 meters 20.
2 meters 20. And can you explain why you think that?
Well, the fence next to him, I thought could be 1.10 meters, and then that's sort of like halfway, or it's a little bit less than half, more than halfway. So because you want me too high, so that's why I went for what did I say, 210 or 220?
220.
Yeah.
Okay, nice. Nicely explained.
Brendan has put in 3 meters.
And how did you come to that, Brendan?
Oh, I just know that no one has ever been 3 meters.
Okay. Any other estimates that would be too high?
I reckon 10 meters would be too high.
Mm-hmm. And what's your justification for saying 10 meters?
I quite like rounding things, so 10 meters, but if it's too high, then that's definitely too high. And I imagine that students in my class might say things like 1,000,000 meters would be too high. You know, they'd go all sorts of crazy numbers.
So what would be a reasonable estimate that would still be too high? So we actually bring in a bit of number sense here. Because you're right, some children will just say, oh, they're 1,000,000 feet or whatever. But we do want to bring in that number sense alongside it. Would 2 meters 20 or 3 meters be a reasonable number sense estimate for too high?
3 meters might be to a child if they don't quite understand sort of, what 1 meter is, but it would, be a lot closer to them saying, oh, he's 100 meters tall. So yeah, 3 meters might be quite reasonable.
Absolutely. So we want to bring it down into something at least that's manageable for them to conceptualize rather than just those random numbers. Anything else on the too high estimate from anyone? Okay, what about a too low estimate? With some number sense involved.
1 meter.
And your reasoning for that would be?
He's an adult, and most adults are taller than 1 meter.
Good reason.
1.20 m, because having done a little bit of fencing, I know that sort of those fences are often 1.20 m.
Ah, so you're bringing in some prior knowledge there, which is really good too.
I guess
Anyone
30,
else?
30 centimeters, because 30 centimeters is only the size of a normal ruler.
Aha. So would that be a number sense too low estimate or just a random too low estimate?
I guess it would to a child it might be. I guess you're right. It would just be a random estimate.
Mm-hmm. Because kids sort of know how long a baby is generally, don't they? That's something most kids can understand, isn't it? So it's around that benchmarking too of what's familiar in their world. So now for everyone, what do you think is a reasonable, close estimate for his height?
I would say close to 2 meters.
Okay. And again, can you justify that reasoning?
First of all, I mean, he's very tall. You can tell from the fence.
Mm-hmm.
And coming back to my too high at the beginning, where I said 2 meters 20, which was definitely too high, because I think he's definitely not that one. Because his body, so the fence around, I would say it's probably 1.20 m, and obviously his bottom half is longer than his top half.
Right. So when you say close to 2 meters, do you want to be a little more specific?
Ooh. 1.95, step in the dark.
Okay, that's a pure guess. All right. Somebody else?
I'm going to go 1.85 m.
And your reasoning for that?
Just again comparing it to that fence, and he does look pretty tall. I don't think he's 2 meters, but yeah, he just sort of somewhere in the range 185 to 190.
Mm-hmm. So we've now got that benchmark that fences are around 1.20 m, is that right?
If I'm right, yeah.
Yeah. Someone else, what do you think would be a just right estimate?
Good everyone. Sorry, I've just joined. Michelle Ciolo here from Wesley Intermediate. I'm going to go with 180 because I'm 163 and the fence is 120-ish. then my guess is probably an extra, 20 centimeters above me. So that's my rationale.
It's great. So you're using your own height as a benchmark, and you are visualizing what you know about units to make that estimate.
Yeah,
Okay.
that's-
Someone else? I'll do a reveal in a minute if there's no one else.
I'd say about 190.
And Esther, what's your reasoning for that?
Again, going with the fence being about 1.2 and then adding on the height I see on him. So that would be and knowing also my height.
Right.
So I consider he's actually quite tall.
Nice justification. Right. Anyone else before I show you the reveal? Okay, here he is.
1.93.
So we've got two things going on there. We've got his length, or the distance of his height, but we've also got the measuring attribute being used, which we were using in meters and centimeters, and that understanding of how that works. So there's fathoms there as well, which is a very old sort of measurement unit that's often used for in the water for deep sea. There's a story, something under the sea, and they talk about the fathoms. So the unit that we use to compare with for the height is very important. Anyone like to respond to that? Okay, I'm going to bring up the next slide. Then I'm going to ask you to jump on to the interactive, which you've got the link in the chat. So same guy, and we know his height now of 1.93 m or 6'4". So knowing that, how tall do you think that lamppost is? So I'll just give you a bit of think time. So if you go into the interactive link that was in the chat.
I'm sorry, Kim, I can't see it in the chat.
It was the very first, yes, at the very first from Cognition Education SharePoint.
Can you pop it in again? Sorry, I think that if people arrive late, it won't be in the
Right.
chat.
Let's do it again then,
Cool, thank you.
just to make sure you can all get it. So can you see it now?
Yeah.
Great. I'm just going to minimize the chat. So if you go onto that link, everyone, you can still see the photo of how tall is the lamppost. And we should all be coming into the interactive site, all going well.
See lots of people's initials coming up, so that's good.
Okay, so on the next slide, you should be seeing this one. Choose a colour and put in an estimate that you think is too low. And then on the other side, using the same colour, put in an estimate that you think is too high.
Should we choose the same colour in both?
Yes.
Yeah. Okay.
Yes. So in a classroom, you'd probably assign a colour to students so that it's consistent and you can see the initials. And welcome, Heather. Put your sound on, Heather, so you can then take over your part of the workshop. Okay, so I'm seeing some lovely estimates here. And what you can do here is click and 5 meters. So who was on the blue? 5 meters.
It's me.
I can't click into it. I tried to do the light blue one, but it doesn't do it.
On which side?
Oh, on the too low. Oh, hang on.
Somebody's there. Yes, I can see somebody moving around.
Yeah, but it doesn't go in it. It doesn't add.
Oh, there we go. I saw something come up.
Yeah.
KK9.
Oh, okay, that's somebody else.
Ah, yeah.
Here's another color. I think somebody else has gone
What
in
about the
there.
orange?
Orange? Somebody's gone in there.
Okay.
Oh,
Try
well.
bright green or something.
Light green.
Try the fluorescent green or something.
Yeah. But
It should work.
so if I click into it,
It should come up
no.
with it.
Maybe it's just a bit laggy.
It could be because other people's it's working. So I'm going to ask the person that wrote in the deep blue here 5 meters. Can you tell me why you think that is an estimate that is too low?
That was me, Kim. I chose 5 meters because I decided that the lamppost was about 3 of that man, or just more than 3. And if he was about 2 meters or just a bit less, like the previous guy we talked about, so I was cutting it down. 3 lots of 2 is 6, and I went down a little bit more. So I thought that 5 would be too low. That was my kind of rationale. I don't know about that though. Maybe it's actually my estimate's a bit high for the too low.
All right. So the person that put in 3 meters GC, no,
That's
3 meters
guest contributor.
Yeah, in the light pink. Can somebody add on to their thinking there?
I put 3 meters because he's 2, so the lamppost is definitely more than 2 of him.
Okay. So you can see with this interactive, you can choose students to explain their thinking and then type it in here as well. And it just draws out the conversation and helps children to focus in on different things you want to bring out. So going to the estimate, that would be too high now. Now, quite a few of you have put 10 meters as their estimate. And somebody's gone very high for 20 meters. I'd like to bring it down to, say, the 9 meter person. Why did you think around 9 meters, or the person that wrote in 8 meters? Thinking number sense as well, that all this is around having a bit of realistic estimation to it. Who popped in the 8 meters?
I popped in 8 because I looked at him and thought, oh, he's probably about 3 of the lampposts. So I think he's about 6. The lamppost is about 6 meters, so I went for 8.
Okay. So can you see how we're drawing the conversation and the justification and the talk out here, which gives the really rich talk around that estimation and bringing in number sense, which is so important. So going to the next slide then is now pop in an estimation, use the same color if you can, that you think would be just right.
Well, I can't type. Can I just say it's 6 meters?
Sure. I don't know why it's not working for you. It should be. I wonder if I can pop it in for you. There we go. Now, what I'm seeing here now is we've got some whole number measurement, but we've also got some decimal measurement too, or parts of a meter coming in, which then adds to that conversation. If you've popped it in, I'm going to get you to pop in your unit of measure as well, just for clarification if you haven't already. Because children will so often say it's to whatever, and you need that clarification. What unit are you actually using? We might know it instinctively, but it's really important to have the justification. Okay, who's the person that put 4.12 meters? Could you justify or share your thinking around that?
Yes, so I have used the person's height as a benchmark. So that was like 1.93, and I added up. So that's nearly 3.86. And I feel obviously the pole is going to be a bit more taller. So yeah, just added some more numbers or units to it, and that's my answer then. So using his height, doubling his height, and adding some more measurement to it. More units. Yeah, thank you.
And you're visualizing at the same time, aren't you?
Yes.
Nice. How about somebody there that put we've got 2 for 5.9 and one at 5.95, which are very close. Would one of you like to share your reasoning there, please?
I took the man and thought that it was about 3 times his height, and just thought I would take a fraction off, so rounded it to 5.9.
Nice.
Right. Nice.
Yeah. Can I add on to this? Just thinking about that number sense, Kim, and if I was to force my students to not use the terminology point and instead replace that with and, I want you to think about what 4.12, if I replaced point with and, might actually be expressed as.
Nice.
So 4 and 1, 2, or 12 what? So students are then forced to think about what the 12 or the 1, 2 actually means in a measurement context.
So we've got the 4 whole meters. And then they need to understand that the 1, 2 is 12 of something else. We've got 2 units of measure going on.
So we can unpack that decimal place value of hundredths of a meter being a centimetre units in themselves. Anyway.
Very nice. Anyone else like to share their thinking there?
So I went with the so his actual height 1.93. I rounded it down. Although I rounded. I estimated that the height was approximately 6 meters, and then I multiplied the difference, which would have been 0.7 times 3. So I subtracted 0.21 from 6 meters and got 5.79, but I just rounded it to 5.8, which I like the idea, which I learned from Brian's story, 5 and 8 tenths. And that's actually a very powerful way of teaching them place value.
Exactly. Love Brian's story.
Wonderful. Okay, so
I looked at the shadow.
Right.
Oh wow!
Talk to us.
And I basically, had a look where he was standing, and I thought sort of like the shadow from the lamppost to where he's standing is about double the length of the shadow to his other side. And therefore I rounded this to 6 meters because he was 193, and since this is double, so I rounded it to 6 meters because I thought a lamppost is probably a full number. Well, I don't know. It's just thinking.
It's a beautiful right angle too.
Yep.
Okay, I'm going to bring up the PowerPoint now and do the grand reveal. The interactive templates are from a site called Teresa Wills. Where there is a will, there is a way. And she has lots of interactive templates that you can use for online teaching like this and use for a lovely, very focused number sense talk. So here we go there. And the reveal, this is the answer. There we go. So those of you that had 5.8 and 5.9 were very close to the grand reveal. And all the ways that you got to that answer are fully justified in the concepts of measurement. Heather, anything else to add in there?
No. I think that's perfect. Yeah. Estimation being critical. Yep.
So thinking sideways here for you all, how would you measure a bucket? And what would you measure? The site is called Teresa Wills. When there is a will, there is a way.
I'll find the link. I'll pop it in there. Mute.
So, what would you measure for a bucket? Julia's put the height of a bucket. Julia, do you want to manage the chat for me, please?
I'm stuck on this.
Any other suggestions? Just chuck it into the chat, people. What other things could we measure about this bucket? Litres of water, Maddie.
The length of the handle.
No.
I'll say again, what was it about the handle?
The length of the handle. How long is
Oh,
the handle?
lovely. Right. I can imagine that kind of curve, that arc that you see there. That's cool. The length of the handle. Love it.
The length of the around the top compared to the bottom.
The length around the top and
Yeah,
around compared to the bottom.
What do we call that?
Diameter.
Circumference.
Circumference.
Right.
Yeah. So circumference. Great. Michelle popped that in too. The circumference. And Holly's popped in maths or the distance.
Sorry, no, that's me.
Oh,
I
Holly.
seem to be coming up as Holly. I'm so sorry. I don't know why that is.
Sorry, Heather. The maths at distance is her site and lots of resources. Right, that's Teresa Wills.
Yeah, it's linked there. Sorry, that was me being.
All good. It was a direct
off
message
these.
to me, and I'm reading it out to everyone.
That's
All
good. No, well done.
What other things could we measure about this bucket? I can think of one more thing, but I'm going to hold off just in case. Oh, the diameter of the bottom and top. And somebody else has suggested the weight. I like that. I hadn't thought of that one. The weight of the bucket.
Surface area?
Oh, surface area of the bucket.
Oh,
lovely.
very nice.
We've got mass, weight, mass. That's an interesting discussion point. Weight, mass. And I think we could have a similar conversation about capacity and volume. Yep.
Anything else?
We do the height of the bucket from the base up.
Yep.
We could also talk about the coverage of the base on the grass or on the surface it's standing on.
Yes.
Or its bird's eye view coverage.
Or you could put something into the bucket and compare it. So, for example, if you fill it with water and then maybe with pebbles, and then the difference.
Yeah. Yeah.
Notice all the language, mathematical language and vocab coming out of this discussion.
Yeah.
Great.
Oh, here's another one. Strength. The strength of the bucket.
Oh,
yeah, lovely. And perimeter. The perimeter of the bucket.
Beautiful.
So there's opportunity there to explore some of those key concepts too and unpack what some of those things mean if children don't know. So a tip chart, term, information and picture is a really good way to capture all of that language. Anything else before we move on? And Heather, going to hand over to you, your workshop, and I'll assist.
Oh, Kim, how kind. You probably have to manage the slideshow though, because I haven't.
I certainly can.
Thank you.
So from Van der Waal, which I'm not sure if you're seeing, but this is one of our main gurus, Van der Waal.
Teaching developmentally. So Van der Waal is a the late Van der Waal has guided a lot of our the mathematical thinking across, I guess, the Western world for a number of years now, and he has a lovely publication about the big ideas of mathematics and how children learn developmentally. I think his example here, which is really the bucket example, is that there are various things we could measure in a bucket, including all of those things. So but then we have to determine what it is we want to know about the bucket. And if it's volume, then the attribute will be very important. We'd be looking at cubic litres or whatever to measure how much water that bucket would hold. But we might be more interested in other aspects of the bucket or whatever it is we're measuring. So it's just an introduction to the fact that there's weight, volume and capacity, length, and obviously area of those things. So yeah, that's just an introduction to the types of attributes. Yeah, so hopefully the students might know, well, actually, if you're asking me to measure a bucket, what is it that you actually want me to measure?
It's quite good to get them to come up, just as we did with you, all of their ideas that they see.
So they're vested in the interest of what it is we're doing mathematically.
Okay, so knowing about measurement, we need to understand the key ideas in the levels in NZC, NZ Maths. So just pop in the chat what you think are those key ideas about measurement at levels 1 to 4.
Comparison, we've got come up already. Yep. I wanted to add an estimation, which we've already talked a little bit about today. So estimation. Any other thoughts, people? Understanding units, comparison, conversion of units.
Yep.
That's all coming up. Understanding the right measurement tool for the length being measured.
Yes.
Yeah.
Oh, yes.
Yes. Right tool. And like we've talked about the attribute length in that comment, but actually we could be thinking about other attributes as well. So if we think about length, we might talk about what kind of ruler or measuring tape, or maybe it's a sewing measuring tape, or all sorts of a big rolling or one of those roller things. Those all look at length. But if we were thinking about measurement, the same thing applies, isn't it? Really, we kind of go, well, what kind of measuring tool would I use if I'm measuring the weight of a big sack of kumara, or if I'm measuring the weight of some medicine for my cat, or so there's different kinds of measuring tools for all the different attributes that we could consider. Another thing come up here is abstract concrete, that abstract concrete discussion. And we've got reading and saying and recording measurements.
Yes.
And another really important one just seen come up is standard versus non-standard units. So that's a really great place to start, really, at the early levels of the curriculum. That's that conversation of that focus on the attributes, so that we're thinking about the non-standard units and then moving towards the standard ones once we've established the need for a standard unit of measure. Yeah.
Okay, so taken from NZ Maths, key ideas under the curriculum elaborations. Here are what NZ Maths considers the key ideas. So level 1's about comparing and ordering by a direct comparison.
Start to see that appropriate units coming in level 2 there. So we're starting to potentially see the standard units coming through in that conversation.
Then going into level 3, we've got a new word there, metric units for length.
The other thing that strikes me as we see these coming up, Kim, is that it's not just a cumulative thing in terms of length, and then later on we do stuff like area and volume. It's all the way through, you know, it's kind of all the way through from year 1 through to what we're seeing here, level 4, where we're looking at all of these different elements of measurement, all these different attributes that you talked about earlier.
Yeah, I think cumulative is a really good way of describing that, because one builds on the other to build on the other, and then we have this richness as we become more sophisticated.
What's going on here? Let's go back. It jumped. Okay, so going on. So Heather, handing over.
Okay, yeah. So really, and we're using the example of length because it's it seems to be something that that children find difficulty grasping, yet it's something that they experience more of than other measurement tasks often in the primary years. So there are some fundamental concepts that kids need to navigate. So we're just going to unpack some of those, and really it's within their physical environment. So it's got to stay within structures and concepts which kids are familiar with. Yep.
I don't know if it's kids that struggle as well, because when I got lino down in my laundry, it was about 30 centimetres too short for the person measuring up. So it's something that a lot of people need. Here we go. But what do?
Yeah, so our students find measurement difficult. Why do you think that is? And I suppose I'll just give you a minute to think about the reasons why kids find these ideas difficult in the chat.
Yeah, in the chat we've got not sure how to describe measures. Maybe we've come to the workshop today to understand why kids find it hard.
Probably why.
Yeah.
Benchmarking.
Here we go.
Yep. Totally. Benchmarking is critical.
And then there's also the question around maybe there's no understanding of the metric chart. Visualizing units for making estimates.
Absolutely.
So if you think about that with benchmarks, metric chart, visualizing, all those 3 things are quite abstract. They're kind of, they're quite an abstract concept in themselves.
They are.
So yeah.
Anything else in the chat there, Julia?
Knowing the vocab in order to discuss it.
Yeah, and that links to not sure how to describe it, right? So what do I say? Yeah. So language is critical.
Spatial reasoning difficulties.
Yeah, it is a spatial, that's where the geometry measurement thing comes together, isn't it? Because you have to think spatially in order to think about measuring in space and time, so 2 concepts, measurable and countable. And you have to distinguish between them to understand measurement. They're quantitative representations of objects. So we are quantifying. In measurement, we're quantifying how many of those units. So we have to be able to count. We have to use counting skills in order to make sense of that quantity.
Bring that up.
So really, there we go from our very early years, the sequence of counting words. If I can't count, then it's going to be very difficult to measure those units. And a one-to-one correspondence. Oh.
Want me to go back?
No, I think it's fine. It's just, yeah. So you can read that. So there's something, the unit and the iteration of that unit. So that unit is mirrored over and over and over again. And it's in the number of mirrors of that unit that we can count or quantify how much something is, or how long something is in our length context. And comparing the attribute to what has been measured. Okay, so I think this came up earlier. We have to measure with an attribute with a unit that has the same attribute. So that means that if we're measuring a length and it's a pencil or something, then the attribute is the centimetre measure, and it's the mirroring or the iteration of that centimetre that tells us that the pencil is 11 centimetres long, because we have put that. And that's why it's important, because to start with a non-standard unit that is identical. So the cube, the Unifix cube, or the toothpick, or whatever we choose, that is an iteration of that repeated sample, then becomes the quantity of that measure.
You pretty much said that here.
Yep, that's right. So that's exactly what. Sorry, I'm jumping ahead.
No, no.
Yeah.
Good. So to measure, here it is really in 3 steps. So your attribute measured is filled, covered or matched with a unit of measure with that same attribute.
So what I like about this description is that it kind of applies for even any particular attribute that you're measuring. So if we, generalize this idea now to weight, we're saying, okay, if I want to know how heavy, say this cup is, then I'm going to compare it with a unit which has the same attribute as the heavy attribute, which I'm trying to capture in a weight situation. So then I have multiple of those same units that I'm going to compare. And of course, that's quite an abstract thing. So so students will, for example, look at something like a cup, and we might talk about what is the weight of this cup or this item, but they will look at the bigness, because the bigness is the thing that they can see, rather than to actually experience the attribute of weight. And to understand that that is the thing that we're focusing on today. So it's really quite an interesting one to discuss, and to even kind of push the envelope on something which is bigger but lighter. So this is bigger but lighter when I'm thinking. So, and kind of breaking down those that conversation, so that we're not always conforming to heavy things being bigger, because we're going to end up with with not really drilling into the attribute that we're trying to get to. Attributes are kind of a word that we would use amongst teachers, but not really one we would talk to children. We would, keep using the language of the thing. So how heavy is it?
Measure,
which one's, which one's lighter? Which one's heavier? How many of those makes the same as that? That sort of conversation. But for our, kind of pedagogical content knowledge, we're going to use this word attribute, because it really drills into the important thing to focus on.
Yeah, it's more specific, exactly.
Yeah.
Perfect. Okay, Kim, moving on.
So the concepts required to understand length, there are at least 8 conceptual understandings to build this understanding of it. So there they are from our research, but what do you think they mean? Let's have a share together. Any ideas?
So we've probably discussed attribute, we've probably discussed equal partitioning, which is that unit iteration, which is pretty much, they sit in the same zone. Accumulation, which is that counting, or that additive quantity of repeating those things and adding. And the relationship between number and measurement has been explored, but I'm wondering about transitivity, conservation, and origin.
Any ideas from people out there?
Conservation makes me think of being back at Teachers College and learning about Piagetian work, that kind of if I pour the liquid from this tall container into this fat container, that's a developmental phase that we know that children go through, and no doubt you've witnessed in your classroom.
Yeah, especially if you teach those 5 to 7 year olds, you'll see them move from that through that conservation notion.
Origin has just come up. Brendan's just chucked that in there. Origin is that understanding why certain units are introduced.
Yeah, okay. I think to some extent it is, Brendan. I think when you look at the literature, origin is the start point. And I think tasks like the broken ruler task pick out origin. So I can actually measure the length of something if my ruler actually has snapped off the bottom and starts at 12 and finishes at 100, and to go from 12 to 20 means that I have got a measure of 8 units, whatever those might be, and they're probably centimeters in that context. So origin is that start point of where I'm actually measuring from, which is important because I could measure anything.
Look, I've seen high school kids not having the correct starting point, not really attending, if you like, to that origin of their measurement for length. Hina, sorry, has just added into the conversation there a conservation, converting to another unit, finding measurements of the same object in 2 different units. Yeah, that's a good.
So that's our centimeters and inches business, isn't it?
Oh, and meters and centimeters too.
Yeah. The amount of times I have to Google Fahrenheit to Celsius when I'm baking.
Okay, so just going through them.
Yeah, that's it. So attribute, length, span, fixed distances. So here's a little child using those little tiles to measure that object, and they're an iteration of that same sized tile. Oh, the length and origin. So if I move my table to another orientation, it'll still be the same length.
And in terms of capacity, we just talked about there, or volume capacity, we were talking about a liquid. So as it moves, it doesn't change. Area is another interesting one, that we can have 2 different shapes that have the same area. And that idea of conservation of area. If I start with a rectangle and then rip it and reform a shape, then the area has stayed the same. That's the same concept.
Because it's the same space coverage. Yeah. Oh, cool.
Same 2-dimensional coverage. Yeah,
I like that.
Okay. Transivity, which we do a lot naturally in life, but I don't think we consciously do it a lot with children. And I think it's very hard for children to do that unless they can line them up side by side, whereas as adults, we do a lot of imaging without realizing. And we showed that with the lamppost and the height, etc.
Yes. And if I try to move my bed from my upstairs to my downstairs, will it fit through my narrow stairwell?
So the equal partitioning. So quite a few people were doing that with the lamppost.
Yes.
The unit iteration. Yep. Accumulation. So it's covering the space.
Yep.
Origin that you've just touched on. Additivity.
Yeah. Length can be decomposed and composed, so we can actually, Origin's there again. Okay.
Okay, so with measurement, we've got that counting stuff going on too. Kids are learning to count at the same time.
Yeah, so the context for this was length. Obviously, length is an additive concept. It can be multiplicative, but when we think of area and measuring volume and area, we have to apply multiplicative thinking.
That's right. And that's an interesting one when you start doing conversion of units in area. So, if we increase the area, if we increase the size of say, for example, a square or a rectangle, actually any area, by a factor of 2, then the area actually increases by 2 squared, and the volume
2 times 2.
Exactly. 2 times 2, and then if it's a volume, 3 times. And that's a really big sticky point later on.
It's huge. Yeah, and you see that in year 9-10, Julia.
We do, yeah.
So just want to draw your attention to book 9 in the number framework series, the pink book, number 9. But there is this chart in there. What do you notice about it?
I think that a lot has to be built in those early level 1 stages.
Yeah.
Not quite
What
sure
would
what the
you
words say, Kim. Sorry, what do those on the sideways? We've got attribute concept, so that's being developed all the way through to AC.
So length, area, mass capacity, weight, time, and what's the last one? Temperature, is it?
Temperature?
Yeah, so I guess time seems to take a longer time to become
Weight
embedded.
and capacity and time take longer to get embedded.
Oh, weight capacity, yes.
Right, so we would spend longer with the students on the attribute concept before we would start talking about the unit concept and developing. What's the last one say? Scale concept.
Scale concept, yes.
Thank you, Hannah. You've just put attribute concept knowledge is important and constant. Yeah, so all the way across, you've got that attribute concept is critical. And then Brendan's added in understanding scale is underpinned what is below. Absolutely. So you don't want to be going into those formal units and that scalability of those units until you know that you've got that other business, this unit concept and attribute concept solid for the learners. That's right. It is a cumulative, a progression. Yeah.
And multiple representations.
Yeah.
Absolutely. So just an awareness that sometimes we jump into teaching kids these concepts too soon, or they're not ready. Developmentally, there's a wee way to go. It's an awareness there. So getting on to the activities, Heather, the first one. One we would do quite naturally, I think, in our junior classes, picking up a couple of objects in the room to measure them with non-standard items and then doing a comparison. So out of those.
Sorry, Kim, I just had an interruption in my house.
Which conceptual concepts would that activity support, do you think?
Standing scale, units and iteration. I want to say there.
I think you're right. I agree.
Origin,
equal partitioning. Yeah, so it's like you can't focus an activity on one of those, but one might be highlighted more in an activity. Yeah.
So we're always thinking, what can we get out of an activity to bring the most out of it?
And build on the last one. Exactly. Yeah. This is a great task because it really does require that estimation, benchmarking, and all sorts of things. This is actually from Van der Waal. So, putting masking tape on the floor or a string or anything and making these kind of pathways like this, it really does, put kids into a really, really important measurement idea. So really just how could you determine which of those pathways was longer? Another great task, I don't know if it's there, Kim, is that do we do the meter on an A4 page?
Yeah, we're coming to that.
Yeah, we're coming to that. So think about this when we come to another task in about 5 minutes. Cool.
Okay.
Yep. And then to create one that's as long as that path C, gosh, that would be interesting. Another pathway.
And how can they justify it too?
That's it. It's actually being able to describe and justify their thinking.
And then actually prove that it's right or not at
That's
the end
it.
of it. So that kind of,
mathematical proof.
Yeah. Nice.
Love it.
And particularly when you've got the crooked lines too.
Yeah.
There's a lot more cognitive thinking going on than just two straight endpoints.
And that's the point, Kim, is that typically in primary schools, kids are expected to measure a straight length. The world isn't like that.
And yet when we teach measurement, we tend to make it like that.
Yeah. Yeah, so transitivity, that I can work out which one is longer. I'm comparing A to B to C, comes into play there. Cool.
I'm just conscious of time. We're going to run out of
So
time
am
soon.
I.
I'm just wondering whether we can flick through a couple of more of these activities.
We're
Just to
we're
bring
nearly
us
we're nearly there.
fantastic.
So you've also got the unit iteration there with this task, particularly if you're visualizing it like you would be the lamppost. This is a wonderful story. Heather, you use this one a lot.
I do. I love a story. It's just basically the picture book talks about the king wanting to make a bed for his wife's, the Queen's birthday. And he goes to the little royal carpenter and tells him that it's 6 feet long and 4 feet wide. But the carpenter's feet are about a quarter the size of the king's feet. So he makes this little baby bed. And so it just points to the fact that if we're talking about a unit, it has to be standardized. So if we're going to talk about a foot, it can't be your foot compared to my foot. It has to be what we determine to be a foot. It's just lovely. Anyway.
A follow-up activity.
Yep. So using their footprints to measure the length of the whiteboards, and we can work out, how many feet you had and how many I had. Yep.
Certainly brings in the attribute of iteration too, doesn't it?
It certainly does.
It's also got a couple of key ideas in it.
Yes, the larger the unit, the smaller the measure. So that's yeah, it's really interesting.
We assume students understand that, but actually we need to deliberately teach it. And they're not always whole numbers. And those standardized units are needed for effective communication.
Yeah.
So just around a common misconception. That when children are measuring, they think they're counting the dashes.
Not the actual iteration of that unit.
So it's the space in between the marks. Are there any other misconceptions that you might come across in your teaching? We've just got a couple more to go. Anyone got something to share?
From 1 year.
Yeah, somebody's just added in there, when you use a ruler, start from 1, not 0. Or
Yeah.
0. Yeah.
Because 0 means nothing, doesn't it?
But that space,
Yeah,
0
that's
and
right.
1 doesn't exist.
That's
And of
right.
course, we know it does.
Mm.
And particularly those rulers that have the space before 0. They've actually got to start at 0, not necessarily the end of the ruler.
And that the first unit, the first measure is between 0 and 1, and whatever quantity between 0 and 1 that might be.
So they're really important to address when we're looking at measurement. So you talked about the broken ruler earlier, Heather.
It's a really useful way of showing kids that you have to actually count the units, not start at 0 or whatever.
And that you're counting the spaces.
The spaces, that's what you're counting. Yeah.
And some of the conceptual concepts that the broken ruler activity might address.
Yeah.
So coming into the role of estimation, why is it so important?
Because we do it all the time. It's a human. it's critical.
So I think the first point there is really important. It helps us focus on the attribute being measured.
Yeah, and it's about accuracy. We've got Brendan just added that in there, that it's also about becoming accurate.
Yes.
Yeah, and it helps us as teachers as well if we always have the rule about estimate before measurement. It gives us a little bit of a window into what the children are thinking before they start with their measuring task. So that's one of the rules that I have in my classroom, is that we always estimate before we start measuring, because we want to have a sense after we've done some measuring. It doesn't make sense. Like, have we got that kind of critical mind to the measurement that we've just done?
Yeah.
Important for developing number sense.
Totally.
Yeah,
totally.
Yeah.
And
I
then
love that
those
idea too of estimate being more than just a guess. That,
Yes,
you know, there's
yes.
this whole business. Like, I have a lot of children that come to me who have this idea that an estimate is a guess, rather than a well-constructed kind of argument of why you think it's that.
Yeah, unpack estimation is not guessing. It's actually having sense to make it as close as possible. Yeah.
So some personal benchmarks could be, we often talk to the children about body benchmarks, especially in the juniors. But how do you teach them what might be 10 centimetres and how do they know?
Yeah.
So here's your A4 piece of paper activity, Heather, coming up.
Good. Okay, so this is a really cool activity to do with kids. Give them a piece of A4 photocopy paper and ask them to draw a line that's a metre long. And if we had more time, I'd ask you to do that. So think about if I asked you to do that, what would you consider as your benchmarks to be able to do that? So all you've got is an A4 piece of paper and you have to draw some sort of line that is a metre long.
Things people come up with, Heather? I'm just thinking about time. What sorts of things do people come up with?
This is our last slide.
So yeah, 30 centimetres. So there's your first benchmark. We know, because we're adults, we know that an A4 piece of paper is approximately 29 centimetres long. So 30 is good. So how many lines, and then I've got a few centimetres to go across because I'm continuing it. Do I go up and down that piece of paper to get to a metre? Well, I have to use multiplicative thinking because 3 times 3 is 9. So 30 times 3 is 90. And then the little bits across might make up the additional 10. So if I've got a piece that's got 3 long lines and a little bit across as a squiggle, then I'd possibly have about a metre. So it's from Peter Sullivan's work, actually. I love Peter Sullivan's open-ended mathematical tasks. Yeah.
So everything that's been presented today has come from research. There's some lovely ideas on NCTM and Peter Sullivan.
Yeah, Peter Sullivan's work's lovely.
So I'm going to stop sharing now. Any comments or questions?
On a humid, hot Auckland day.
It is.
We've had a couple of questions about the Queen story. So there's a YouTube clip to that story that you can use. Yeah, I popped the link in the chat. Yeah.
Thanks, Julia. That's perfect. Thanks for doing that.
And we've also had a question just about the slides, the PowerPoint slides, that people would like to have a copy of the slides, which I said we would circulate.
If you email me, I'll put it in the chat now. I'll send it back, attach it.
No, I was meaning for the participants, the people. I think Jenny will organise that. We've got
we can organise that through your mailing list because you've registered. So I think we can get Jenny to send you that out. And that would be perfect.
Okay, we hope that's been of use to you. Happy measuring.
Happy measuring. Happy end of year for everybody as we end a very difficult year. But next year we can go forth and measure a lot.
Thank you.
Thank
Take
you.
care, everyone.